Okay, so finally now we can see how the event-driven design can be implemented in a much simpler way in Eiffel. So the main confusion about implementing this in Java is you have to handle the method handle yourself manually as a programmer. But such details will be hidden when you try to program this event-driven design in Eiffel because they simply support a very easy keyword called agents. So that's something we'll see. Okay, assuming that you have understood the details from the previous Java implementation, conceptually it's really doing the same thing in the Eiffel event-driven design. However, many details will be hidden from the programmer side, so we'll see. Okay, first of all, we'll start with the event class right in the middle. So for the event class, we can simply say we declare this class as a generic class, and we got arguments as the generic parameter, and then it must be a descending class of tuple. So this is a constraint genericity which we spoke about before. So every argument you pass over here to instantiate this class must be a subclass of tuple. Basically, it has to be a tuple. Okay, let's move on. And we have actions over here. You can see the actions similar to the hash table in the Java implementation, but now you can see somehow it's simplified. So now we say we got a list rather than a hash table. And we now don't have to store the objects like the context object anymore. It's kind of implicit in the case of Eiffel. So now you can think about procedure here. It's a library class that's kind of similar to the method handle in the Java case, right? That's just a library class we're using. And the arguments over here depends on whatever arguments you're passing over here. For example, if somehow we instantiate events by using tuple of a single real number, and this will be instantiated accordingly using a tuple of a real number. We'll see example in a moment. Okay, and then we simply create empty actions, very similar as before, and then subscribe. It's very easy. So we simply you can write some contracts over here, and then just to say the action does not exist previously, and then we'll simply extend that particular action, right? And then we also do publish, which is defined in a very similar way as we did in the Java design. So now we simply just go over all the actions, and now you can think about actions. The item is of type procedure, right? It's simply like a method handle. So now we simply say call. It's similar to the invoke with arguments that we did before. So conceptually, we are not really doing anything different. Okay, and then that's it for the event class. It's a very simple event class, and you can see what we just discussed in a similar manner. So we just talk about this particular middle level, the event class. That's what we talk about the module. Let's talk about subjects followed by the observer. Okay, we'll see exactly how to do that. So now let's first of all go to, you can also see the points I just mentioned before, right? You can read the slides. Okay, weather data, the subjects. So we basically got all the attributes as before, and also we got correct limits in order for us to write class invariants, and also the constructor, right? These are conceivable. Okay, and then we got basically got different events over here. We got change on temperature, we got change on humidity, we got change on pressure. There's only one single event that's necessary. That's why we're using once over here. Okay, it's not really exactly singleton pattern we are doing. We just make sure there's only a single event that's going to exist, but we don't need like an event access class like what you did in the singleton pattern. It's not necessary. Okay, and then you can see that here, this is how we instantiate the event class, right? You can think about this part here is the arguments parameter that we talked about in the previous slides, and then simply a subclass of tuple. Tuple is a subclass of itself, right? A descendant class. So this is saying that every time you want to call the update operation for the change on temperature, you have to give some argument for what's the latest value for temperature, what's the latest value for humidity and for pressure and etc. Okay. And then we say set measurements over here, similar as before. So now we're going to say, first of all, we update the local copies for these measures in the subjects. And then we're going to say change on temperature dot publish, very similar as before, right? So now we just have to make sure we pass a tuple. So we just say tuple contains only a single value. Depending on what how many arguments the update operation will actually require. In case you might require maybe 2 argument value, in that case we will just pass 2 arguments. That's why we're using a tuple, which can allow as many argument values as you need, but in this case just 1. We're going to publish for humidity, publish for pressure as well, right? Very similar idea as before. So now the fundamental change will be on the observer side. Okay, let's see. So we got the make over here. So now how do we do subscribe? You can see we don't need to really use that find virtual, to really find out the update handle and also humidity updates. Update temperature handle and also update humidity handle like in the Java design. We can simply say the following. wd.change on temperature, which gives you events, and say subscribe. So now all you gotta do is to simply use the agents. And so now we'll give you more ideas about how to program agents maybe next week. For this week, all you need to learn about is for this particular restricted usage for the agents for the event-driven design. How do you use it? Think about the agent is like a star operator in the C programming language, roughly speaking. So what we're doing is, rather than simply call the update temperature right away, we're basically passing an address to that particular command. That's what we're doing. So that's a keyword you have to learn. And also we can also subscribe a pointer to update humidity command. Okay. And we also saw this syntax previously when we do unit tests, right? So whenever you want to really give some Boolean query, or maybe Boolean or maybe a command for the test, in that case, you will simply say agents, right? So now that's a similar usage. Again, we are really passing the address for or pointer to this particular command. That's about it. Actually, you can see it's greatly simplified because the agent keyword is something that Eiffel as a design language supports at this level. Okay, and then we got temperature, we got humidity, right, for the current conditions. And then, you basically got these two update commands. And then, rather than passing them directly, so we got to say agents, right, when we subscribe. That's, again, just emphasize. Okay, and then notice one thing here. So when you say agents and command, for example, you say update temperature. In the case of the Java design, we also need to pass a current class, right? We've got to say current or this. But now in Eiffel, you don't need to do that explicitly. Implicitly, when you say command over here, you really say current dot. So that's a current object over here. It's implicit. That's also stored when you say agents. So you don't need to worry about it as a programmer, but it's only done basically behind the scene. Okay, so these are the classes. So now we're going to go over just the same test case over here to see how things will be working at a runtime. Okay, so now let's switch to the iPad over here. Very similar execution flow over here. So I'm gonna just simplify the manner just to outline to you, underscore to you the critical differences. Okay, it's really about the observer subscribing. Okay, as usual, we're going to first of all set up the subjects. So 9, 75, and 25, right? So the runtime structure goes like this, right? A little bit different, but we'll see. 9, 75, and also 25. Okay, and then let's now move on to the observer. So now when we try to create CC over here, passing WD, right? So now if we go to current condition over here, you can see the constructor is rather simple. We simply basically subscribe to the two events, change on temperature over here and also change on humidity, right? So there's a typo over here. This should be humidity. Okay, so we're subscribing to different events and then we'll simply pass whatever that will give to us by the agents. As I said before, conceptually you may think about agent is like a star referencing operator in the C programming language to get a pointer to that particular function. So these two are just going to do the following. So when you say agents.update temperature, it's basically going to give to you this particular procedural object, like a method handle. Okay, and then that one there is going to give you the same information, right? The context class and the name of the update command, and also the signature is a command, also taking a real, similar to the Java design, right? Conceptually, and also what's the implementation. And once you get this particular procedural objects, the actions over here is going to be a linked list. So now the first elements there over there is actually going to point to this particular procedure, right? Similar as before. And now when we do another one, we're going to say over here, change on humidity. So we're going to update that as well. So what about humidity? So now humidity is over here, this particular event, right? So now update on humidity. Again, since we are calling this particular agents, right, over there, just remind you. So this is the agent expression that we're talking about, update humidity. So we're going to, is that one there is going to return this particular procedural objects. Again, so this is like a method handle. So current condition, update humidity, and also taking a real is a command, and also the implementation. So that one there, so that means the change on humidity events is now going to grow the size of it of the linked list, only a single cell, and that one there is going to point to this particular procedural objects. That's about a subscription, right? Very similar to what we did previously, but now you can see from the programmer's perspective, you can now see it's much easier. You just need to say agents as opposed to find virtual and then pass all the necessary information to return the method handle like in Java. Okay, so that's about this particular line. Let's now go on to really to see set measurement as set measurements over here. How do we set the measurements? So let's say 15, 60, 30.4, right? So now if we go to metadata and you go to set measurements over here, right? Let me make it a little bit bigger for you. So now you're going to say, basically, first of all, change the local copies for temperature, pressure, and also humidity. Let's do that first. 15, 60, 30.4. 15, 60, 30.4. Okay, let's do the local copy change first. And then you're actually going to do the publish. So now when you say publish, you're going to say change on temperature, publish, and also change on humidity, and change on pressure will be done in a similar way. That's not relevant for our example over here. So now when you say publish, it's going to require the arguments for you to call that delay execution. So now you simply just be a tuple. And now remember that the publish, let me just show you this. You can see over here when we do publish over here, again this should be arguments. Okay, so now let me just show you one thing here. Remember when we declare change on temperature, we actually say tuple real, right? So that means this particular argument has been instantiated by tuple of real. So every occurrence of the arguments, for example, this one here will also be replaced by tuple of real. And also similarly for subscribe, that will also be a tuple of real for the procedure. Okay, just want to show you how this can be used. So now, in order to call this, we're just passing a tuple real. In this case, just the temperature, right? And then for that one, there is going to go over all the actions, and then this particular one, action the items of type procedure. Now let's go back to the diagram. So now when we look at the change on temperature, there's only one action that is actually stored over here. So we're going to call this particular one. We're going to invoke. And the way to invoke is simply say .call. That's all we're going to say, right? It's like an invoke with arguments. And we call that is going to basically do the temperature is assigned to T, right? And then the value we are trying to pass as argument would be simply whatever set measurement it is, right? So now for the temperature, you can see it's actually 15. So now we're going to change the temperature to 15 and change the humidity to 30.4. Okay, let's do that. So now that means it's going to update it to 15, and similarly it's going to update this to 30.4 over here, right? So you can think about another publish that we have to do is exactly over here, the publish. Okay, the publish, which is going to be on the humidity. So you can see for the humidity, we are actually pointing to change on humidity. This is the events, and that one there is really pointing to this particular procedure. And that one there is going to cause the updates on 30.4 because we just execute the update humidity, right? So it's a very similar flow of execution as before. So after the set measurements, after the two publish, so now it's guaranteed that information are up to date. So now when you say cc.display, it's guaranteed that we're actually getting the two most up-to-date data that's actually accurate. And let's do it again. So now if you try to do one more, if you try to set the measurements once more, 11 and 20 specifically, right? So now we're going to go over the process again. When you say set measurements, you're actually going to publish and publish to the temperature and humidity events over here, right? So that's going to be 11 and 20. So first of all, you update the local copy over here to be 11 and 20. In order for these latest measures to be reflected back to the current condition, you're going to go over again. So now for the temperature, you're going to go over to call this procedure once more. So that will update it to 11. And then for the events over here, for change on humidity, you're also going to this particular procedure over here, invoke it, and then that one is going to update the current condition to 20, right? So now when you call cc.display is guaranteed, so now they got the latest measure, 11 and 20, right? So that's about how things work at the runtime. So I would suggest you kind of study the two designs, Java versus Eiffel, together. You can see conceptually what's happening here is very similar. It's just that for the observer, it's much more convenient for you as a programmer to simply just use the agent keyword as opposed to finding out the exact method handle. Okay, so finally, let's go back to the slides and make some conclusion about this lecture here. Okay, you can also read about these two bullet points, which are also illustrated already. So finally, the slide here simply just compare exactly how things can be done in Java versus in Eiffel. So the one that's really inconvenient would be when you want to get a method handle in Java, in which case you can simply just use an agent keyword in Eiffel. Right, there's a contrast over here, right? And also in Eiffel, you just say a procedure like a method handle. You don't have to worry about the current objects. But in the case of Java, you have to worry about the objects. Okay, that's some comparison. Okay, it's simply just because somehow Eiffel is a design language. So to really think about event-driven design, we thought it would be easier for you to have a first exposure to event-driven design using Eiffel. Okay, it's just for learning purpose. Okay, beyond this lecture, I would suggest some optional exercises. We have made all the source code available to you for each of the designs that we spoke about in this lecture. So I would suggest try at least the Java one for event-driven design and the Eiffel one for both event-driven and also observer pattern. Try these three designs. Basically, open up, launch the project in the relevant programming IDE and try to set the breakpoints in using debugger to see if how they work at the runtime correspond to exactly how I visualized to you during the lecture. Okay, so that's about this lecture here. Review the two patterns, understand their motivating problems, and also try to see how things work at the runtime when you implement them.